Hi, everybody. Today we're going to talk about the cubic function family, and we're going to review what we learned about transformations earlier in the school year. So the first thing we need to know is what is a parent of the cubic function family? The equation is the most simple form of a cubic function, or y equals x to the third. To create a table, I'm going to use the same middle 5 points that I have been using. I'm going to substitute in -2 to get -8, -1 to get -1, 0 to get 0, 1 to get 1, and 2 to get 8. These 5 points are going to help me get the parent graph of this function. So I'm going to plug in -2, -8, -1, 1, 0. We always want to try to get 5 points on our parent graph or on any graph of a cubic function because it helps us get the shape of a cubic function. If we only have the 3 middle points, we're kind of tempted to draw a straight line through it, which is not what the parent graph or what the cubic graph should look like. So we always encourage 5, but you'll see in these types of problems, sometimes 5 points on a graph is kind of unreasonable, so we have to do a little bit of adjusting. The domain and range, this is a positive odd function. Odd functions, the domain and range are super easy, always -infinity to positive infinity. So here is our starting information for the cubic family. Now, this cubic equation, the parent equation, there is an assumed set of parentheses around the x. And that's how we start talking about the inside of the function or the outside transformations. It's that assumed parentheses around x. So we want to remind ourselves how to describe transformations. If you need to go back and get the function transformation table that you did in Unit 2, feel free to go grab those notes or even go back in Google Classroom and try and find those notes again. So we always work from the inside out. I don't have a shift left or right. So the first one I actually have to describe is this 1/3 on the inside. That's a horizontal transformation. And on the inside, we know that we always deal with the reciprocal. So whatever this is, it's going to happen by 3. If it's happening by 3, it's getting bigger. So we're going to say it's a horizontal stretch by a factor of 3. Remember that the negatives are their own transformations. So this negative here is a reflection about the y-axis. And remember to use words like reflect instead of flip. We move to the outside now, and what's multiplying the inside is this 1/3. On the outside, it's a vertical transformation, and it stays the same. So if we're cutting something down by 1/3, we are shrinking it or compressing it. So that 1/3 being multiplied on the outside would be a vertical shrink by 1/3. And last, we have a subtraction of 2, which would mean we move down 2 units. We know that being able to describe transformations helps us graph these functions. And we know that we have to describe a function in a specific order to make sure that we actually are describing the equation or the function that they give us.
So first thing that I like to do is to write out my transformations, to talk through what's happening to this graph, and then go through the table of values. So we have going on right here, we have a -2, which means that we are going right 2. And then we have a negative out front of the x. So this is telling us that we are reflecting over the y-axis. Then we have the 3 on the outside, which is then telling us to vertically stretch by a factor of 3. And then we have the plus 1 at the back, which tells us to go up 1. So just like we did with quadratics and absolute values, we have the parent table to start from, and then we apply our transformations to that parent table. So the parent table is -2, -8. Think about what -2 cubed is. That gets us -8. -1 cubed, -1. 0 is 0. 1, 1, and 2, 8. Okay, so just like numerically, we said we went right, and then reflect over y-axis. We're going to do the same thing in regards to our table. So we want to go right 2 first, which means that we are going to add 2 to our x values. And our y's will stay the same for now. Next thing that we do is the reflecting over the y-axis. So that requires us to multiply all of our x values by a -1. And again, our y values do not change. Next, we do our vertical stretch by 3, which requires us to multiply all of our y values by 3. So now our x values are going to stay the same. Now we're going to change our y values. And last, we go up 1, which means that we are going to add 1 to all of our y values. So as you can see, the first point and the last point are not going to fit on the graph we have because we have a 10 by 10 graph, and that's okay. As long as we make the general shape using the middle 3, we will be okay. So we need to graph -1, -2, -2, 1, and -3, 4. Remember, this is a little bit of a squiggle in the middle. It is not a line, so make sure you're not connecting this with a line. So typically we would be coming down like this, a little bit of a curve, and then curve a little this way. Because we vertically stretched, it is stretched out, but there is a little bit of a curve in there. As for domain and range, your domain and your range for your cubic function are always going to be -infinity to infinity. Again, domain is how far left, how far right, and range is how low to how high. So both the domain and range for this equation of the cubic will be -infinity to infinity.
The last skill you need to have with your transformation is being able to write cubic functions either from the parent or from an original function using transformations. So we're going to go through our list in the order, and we're going to transform this original function f of x equals -3, x minus 1 cubed plus 2. My first transformation says to move left 3. I remember that left 3 in function notation says add 3 on the inside. Well, this function notation tells me in my function, replace x with x plus 3. To simplify that, we would just add our like terms and get -3 times x plus 2 cubed plus 2. My next step is to move down 6. In function notation, that means take your function and subtract 6 from the end. So we're over here, take my function, copy it down exactly as it is, and subtract 6 from the end. Well, I can combine those like terms and make my function currently look like -3 times x plus 2 cubed minus 4. A vertical stretch by 7 in function notation looks like 7 f of x on the outside being multiplied. This is telling me to take my entire function and multiply it by 7. My function here has 2 terms, so I need to make sure that I use my distributive property or use parentheses. To multiply the term with the parentheses, we just multiply the coefficient out front, not inside the parentheses, and then 7 times -4 is -28. And then the last transformation is to reflect about the x. And then our last transformation is to reflect about the y-axis. In function notation, this says a negative on the inside with x. This function notation is telling me to replace x with negative x. Replace x with negative x. So we get -21 times negative x plus 2 cubed minus 28. After I'm done with my list of transformations, I have to remember that they asked me to write an equation. So I always need to give my new equation a name. I'm going to call this function g of x and put an equal sign in there so that I make sure that I'm writing an equation of a polynomial. So remember, if transformations is something that you need to go back and find, you have notes on transformations and function notation in past lessons.